Hello, this is Mr. Hopkins. Today we're going to be looking at our second lesson on binomial distribution. Today it's all about cumulative binomial distribution. First of all, what we're going to do is we're going to do a quick recap. So in a packet of 25 seeds, there's a 15% chance of a flower being yellow. What is the probability of getting exactly 3 yellow flowers? So the first thing we have to do with this is we have to define our random variable. So we're going to say let random variable x be the number of yellow flowers. We're also going to say that x is distributed binomially with 25, 0.15. That's our number of trials and our fixed probability. Now, remember when we work this out, one of the things that we're going to be doing is we want to lay it out like so. So the probability that x, capital X, which means our context, that's our random variable, so that's the number of flowers, equals whatever value we're trying to find, is equal to NCR, so N choose R, multiplied by the probability of success to the power of the number of things you want to happen. So in our case, that's going to end up being 3 times 1 minus the probability. So the probability of failure to the power of the number of things that you did not want to happen. So that's N minus R. In our case, that's going to be 22. So in order to work out the probability of x equals 3, so that is the random variable equaling 3, so the number of yellow flowers is exactly 3, so that's 25, choose 3, multiplied by 0.15 to the power of 3, multiplied by 0.85 to the power of 22. And that equals 0.21737 with a load of other stuff after that. So what we can say is the probability of x equaling 3 is equal to 0.2173 to 4 decimal places. So let's have a look at cumulative binomial distributions. If we look at this question, we can see the type of thing. In a packet of 25 seeds, there's a 15% chance of a flower being yellow. What's the probability of getting less than 3 yellow flowers? Now this here is cumulative probability. So if we let, again, the random variable x be the number of yellow flowers, we've got x is distributed binomially with 25 trials and a probability of 0.15. Now in this case, what we've been told to do is find that the probability of x being less than 3. Now, for us to be able to do this, when we use our calculator or work things out or tables like that, what we actually want to do is to get that thing or less. So if it's less than 3 yellow flowers, what I'm interested in is the probability of 0, 1, or 2 flowers. So I could rewrite this by saying the probability that x is less than or equal to 2. And that is me saying the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. So it's all of these things here. But this is the important one that we need to remember. So it's less than or equal to is the format that we're going to be working in. So if we want to work this out, we work out each of these 3 individually and add them together. So I would start by doing, say, 25 choose 0 times 0.15 to the power of 0 times 0.85 to the power of 25. And that works out as 0.017198. And if we were to do the same thing for the other two, we've got 0.0758769, and there's just a load of stuff after that. And then for the probability of you getting exactly 2, you'd have 0.16067157. And a whole lot of stuff. In order for us to work out the probability that x is less than or equal to 2, I want to add all of these together. So I want to add up the probability of 0, I want to add up the probability that x equals 1, and I want to add up the probability that x equals 2. and that actually comes to 0.25374206, which we can round off to 4 decimal places as 0.2537 to 4 decimal places. Now, this is obviously fairly straightforward if you just want one or two things. And yes, it works out reasonably fine if, say, you wanted 1 or less or 2 or less. But what happens if I wanted to find out the probability of 15 or less seeds being yellow? At that point, this method becomes really inefficient. And what I do is I turn to tables. Now, tables, you'll find them in any of the formula books for the exam boards. And a binomial table you'll find towards the back after you've gone through all of the formulas. You'll have had all the formulas for everything to do with your A-level, AS, maths, further maths, everything. And it'll be at the very end, binomial distribution. And the table looks a bit like this. So each of the tables tells you the n value. So you can see I've cropped this, so you've got 25 and 30. And this x is the x that we're looking for. And as is a cumulative table, when I look up 2, it will tell me 2, 1, and 0. It won't tell me exactly 2, but it will tell me 2, 1, or 0. So it will tell me the cumulative distribution. What we do with this table is we look across to find our probability. And our probability of success is 0.15, and we want 2 or less. And what you do is you find where that meets. And you can see that is 0.2537. So 0.2537, and again, you can see that's exactly what we worked out, 0.2537, when we worked it out by hand. And tables are great. But what happens if you don't? Obviously, you can see the table here jumps from 25 to 30. What happens if we had 26 trials or 27 trials? Well, in that case, you'd want to use your calculator. And to be honest, it's pretty straightforward if you've got one of the classwiz Casio calculators. Here's my classwiz calculator. In order to get into the distribution functions, you want to select Menu, and you want to select 7. Now, number 4 would be if we wanted to find an exact value. So the probability that we did at the start, which was the recap, where we wanted exactly 3 seeds, I would go into 4 and I'd plug my values in exactly as I'm about to do now. But I would do that there. Instead, what we want to do is we want to actually just select down and select binomial cumulative distribution. So we select option 1. So we select option 1. And once we're in there, we select variable, which is option 2. And we've got this screen here. So x in our case is going to be 2. So we enter that in. So we enter 2 and then we press equals. And it takes us down to the next line. We know we've got 25 trials. So we put in 25 and then press equals again. And this takes us to the probability. So the probability for this case was 0.15. And when we press equals, we should get an answer of what we've been expecting, 0.2537 to 4 decimal places. And there we go. That's how you would do that using the classwiz calculator. So let's have a look at a couple of different examples which utilize binomial in slightly different ways. In a restaurant, 2 out of every 5 customers ask for water with their meal. A random sample of 10 customers is chosen. Find the probability that more than 4 people ask for water with their meal. Now in this case, this is asking for more than. But what we know is that we have to find that or less. Now, is this binomial? Well, yes, it is binomial. We have a probability. So it's 0.4 or 40%, as in 2 out of every 5 customers. They either get water or they don't get water. We have a fixed number of trials. We've got 10 customers here. This is going to be binomial. If you've got a customer, they may want water, they may not. So what we're going to assume is it's independent. So this is a little bit of an assumption, but by using that assumption, we can work it out with a binomial distribution. So the first thing we then have to say is this. Let x be the random variable, the number of customers that ask for water with their meal. And then we can write out our binomial distribution by saying x is distributed binomially 10, 0.4. That's 10 trials and a probability of 0.4. Now, in this case, it is asking for us to do the following. We want to see the probability that x is greater than 4. Now, that's a little bit more complicated, so let's have a look at this. If we've got 10 customers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we want is more than 4 people. So this is actually what we want. Now, as we know, all the probabilities add up to 1 in a situation. So if I were to take what I don't want away from 1, I can now actually get my probability. So if I did 1 take away, and what am I going to take away? Well, what I don't want is I don't want this situation here. So I don't want 1, 2, 3, or 4. So what I don't want is this section. So I do not want. So I'm going to subtract it. I'm going to remove it. So what I'm actually going to do is I'm going to look up x is less than or equal to 4. Now that is in a format that I can actually deal with. I can look up less than or equal to 4. Let's have a look at the table. So my table, I want to find probability of 0.4. So it goes up in 0.05s. So that's 0.1, 0.2, 0.3, 0.4. So this is the section I'm looking at, and I want 4 or less. So I go across to it and I get a probability of 0.6331. 0.6331. So with this here, I would need to do 1 minus 0.6331. And that comes out with an answer of 0.3669. So that's my probability. But how would I do that on a calculator with the classwiz? So from the main screen, you would select 7, select down and go into binomial cumulative distribution. Again, select variable. Now we're trying to find 4 or less because it's what we don't want. Press equals to insert your answer. We've got 10 and then we've got 0.4 as our probability. Now this will come out as 0.6331. Now in order for us to use this, if you press menu and select 1, that takes us back to calculations, and I can just do 1 minus the answer and I press equals. And I get exactly what we were expecting to get. Let's have a look at our last example today. So binomial distributions may not always be asked in a context. They may be asked just sort of more abstract. And this is one of these types of things. So a random variable x is distribution b, so it's binomial of 12, 0.25. So there's 12 trials and a probability of success of 0.25. Find p of 3 is less than x, which is less than or equal to 7. So if we've got our values, that's the result, 12 trials. Now we want a success of 3, of x is to be greater than 3. So that's 4, 5, 6, and we want 7 to be included. Now, when I work this out and do the probability of 7, so if I did this, which I can work out, it's going to find me all of that. But what I don't want is I don't actually want this bit here. I don't want 1, 2, or 3. So if I find the probability of all of it and then remove or subtract the probability that x is less than or equal to 3, I can find out 4, 5, 6, or 7. So here's my table. I've got 2 things to look up. I want to work out the probability of 7 and 3. And I've got a probability of 0.25. And here is my n equals 12. You can see the next one is n is 15. So these are my 2 values. Okay. So the sum which I'm going to be doing is 0.9972 minus 0.6488. And that is the probability that x is less than 7 or equal to minus the probability that x is less than or equal to 3. And that works out as 0.3484. So about 34.84% chance. How can I do this on a classwiz? Exactly the same method. Enter your values. So we've got 7. Remember to press equals after each one. Our n is 12 and our probability is 0.25. You want to just take a note of one of these, or you want to store one of these. Whatever you prefer to do. So this is our probability of 7. And then if you go back into it, you can then find out your probability of 3, which is that. Go up to here, and if you haven't written it down, or if you haven't stored it and you've just written it down, just type it in again. So here we've got 0.9972184896, and you can just take away the answer. And we get 0.3484. 398722, but to 4 decimal places that would be 0.3484. Going back to this, we would write it as the probability that 3 is less than x, which is less than or equal to 7, equals 0.3484 to 4 decimal places. And that's it for cumulative binomial distribution. Next video we're going to be looking at some more difficult problems, ones that involve more than one random variable. Remember to like and subscribe if this video has been useful for you, and don't forget to ring the bell to know when the next binomial distribution video is coming. Thank you for watching.